Hello everyone, I'm Diana Purdue from Rimway, and I am happy you're all here. Today I'm going to discuss approach training and how to extend teaching and learning time in hybrid mathematics courses. Our to-do list for this presentation is fairly straightforward, as you can see here, and there's going to be time for questions and discussion at the end, but I invite you to ask questions and comment along the way as well. You can use the chat box there to the right, and definitely let me know how things are going. I want to hear from you. Approach training professional development focuses on creating meaningful mathematics tasks that students do. Participants are engaged, thinking, questioning, testing, and evaluating as they endeavor to complete the task set before them. The result of this process is that we learn quite naturally and easily. We learn. This means that the knowledge and skills are stored in our brains in both short and long-term memory. And this happens because of the associations and connections made while experiencing the mathematics in a contextual setting. The learning process is further enhanced by the last phase of approach training, teach. It's well known that the best way to learn something, truly learn it, is to teach it to someone else. The ability to explain and describe to someone else and have them get it is the truest assessment of one's own understanding of and knowledge about a subject. And this cycle repeats and extends throughout the class time. Do math, learn math, teach math. We know from studies of the human brain and learning theory that humans learn best by doing, not by just listening or only watching. And research also indicates other suggestions for instruction that aid the brain in learning. For example, the human brain learns best when information is presented in a context, a framework for reference that allows for connections to previous and future learning. In approach training, we have a motto: no naked math. Now, before you get other ideas, let me clarify. Naked math refers to math without context. Now, for example, let's say you solve an equation and you get x equals 3.5 as a solution. Now, at this stage in the problem-solving process, you should be asking yourself, does my answer make sense? However, if your original equation was given without context, or naked, then you'll have no basis for reasonableness. In other words, if you know what the variable represents, the context of the equation, then you'll be able to determine whether or not your solution is reasonable. Otherwise, you won't, and you'll come to believe that math doesn't make sense, which of course is not true. Don't believe me? All right, let me prove it to you. So you determined that the value of x was 3.5. If the context is that x stands for the percentage of your annual raise, then the answer is reasonable. Depressing maybe, but at least reasonable. But if the context is that x represents the number of buses needed to transport the students for the field trip, then the answer does not make sense. I mean, I don't know about you, but I don't want to be riding on the half bus. Now, research also tells us that humans are social creatures. We learn best in a collaborative setting. In approach training, participants communicate, questioning, explaining, arguing, defending, and justifying their thinking in order to achieve understanding. Students and teachers realize that learning is a shared commodity, not a solo enterprise. So besides content that makes sense because it's given in a context and a social environment for learning, brain-based research tells us that humans also learn best when they're active participants, not passive recipients. In other words, we learn math best when we do math, not watch the teacher do math or listen to someone talk about math. That's why the do component of approach training is fundamental. Now, the last tip I'll mention from this branch of research is that we learn best when we're having fun. Learning should be enjoyable, not drudgery. Now, this does not mean it's all fun and games all the time, far from it. But deep thinking and solving a complicated problem can be very enjoyable and satisfying. Keys to this include tasks that we're interested in, have meaning to us, and that we're motivated to complete. So, speaking of motivation, what really does motivate us to do things, including learn? The answer might surprise you. Previous research indicated that humans are motivated by two drives, one to seek reward and the other to avoid punishment. The old carrot and stick analogy, if you will. However, additional studies revealed a third drive, an intrinsic drive that motivates us, often in stronger ways than the Pavlovian ideas of reward and punishment. The three elements shown here are from a book titled Drive, The Surprising Truth About What Motivates Us by Daniel Pink. And they're informative in terms of how we should approach teaching and learning. Specifically, instruction must be designed and implemented to meet these intrinsic needs. The need to be in control of our own fate, the need to be able to improve ourselves and do better, and the need to be able to learn and create new things as we progress. In approach training professional development, teachers learn to design lessons that incorporate these motivational elements and therefore increase their students' desire to learn. Students become autonomous masters of their own learning process, taking responsibility for their educational experience. In much the same way as that amazingly popular game, Angry Birds, students are invited to mastery via opportunities to improve results along the entire educational journey. Classroom lesson activities consist of meaningful mathematics tasks that fulfill the student's innate desire for learning and creating new things, thus teaching habits of mind that extend to all areas of education. So, what does approach training look like in action? I mean, how's the classroom set up? What tools are used? What's the task like? What's the teacher doing? What are the students doing? What are the goals of the lesson? These are all questions best answered in the professional development workshop itself. However, I'll provide a small sample here in this presentation for those of you who have not yet experienced Rimway professional development workshops. One reasons that I use web-based materials is that they give me the ability to provide specific content information to my students without taking away from class time. Effective and efficient use of instructional time is one of the hallmarks of master teachers, and one way to accomplish this is to ensure that students arrive to class with all the necessary preparation to allow the teacher to begin the lesson at the appropriate starting point. Web-based materials afford the teacher a way to achieve this goal. In addition, after the lesson, web-based materials allow the teacher the ability to require students to synthesize the information and reflect upon their own learning process, to make connections to previous lessons and topics, and to practice in order to ensure understanding and mastery of the subject. So, in other words, the in-class learning is bracketed and supported by the technology-supported learning. Teachers' common problem in face-to-face instruction is time. There's just never enough of it. By adding technology-supported learning, that time is extended, and the students realize that learning can and should occur outside of the classroom as well. So here are some specific situations I faced as a teacher and how I address them in my mathematics courses. One of the most frustrating things I've had to deal with as a teacher is when my students walk into the room not ready for the lesson I'm prepared to teach them. There's one particular class that stands out for me in this situation: probability and statistics, specifically the section on regression, functions of best fit for data. A key component of this lesson involves using the graphing calculator to determine the best function and then using that function to predict future results. But this component has several preliminary calculator-based skills that the students must master. These skills include entering the data into lists, creating a scatter plot to visualize the data, setting an appropriate viewing window for the resulting graph, and then the specific steps for creating each function equation. And initially, I was spending 2 or more class sessions demonstrating these skills to my students, thus leaving very little time for the actual intent of the lesson, which was analyzing the data and making predictions based on those functions of best fit. In other words, the students were not ready to learn the lesson I wanted to teach. And as a result, we all were not spending our in-class time as wisely as we could have. Now, by relocating this particular learning to outside of the classroom, I addressed this lack of preparation problem. In this case, I used a screencasting tool called Screencast-O-Matic to record the calculator skills demonstrations using my computer and the calculator emulator software. I put the links to these screencasts on the course page. In my case, the learning management system used was Blackboard. And then, via a course announcement in the LMS, the students were directed to watch the screencasts and then enter a set of data into their calculators prior to coming to class. And then we use that data in class the next day. That way, if they had a problem in performing the calculator functions, they could simply stop the screencast, replay it, or start all over. Unlike in class, where if they missed it, then they were stuck and couldn't proceed with the lesson or the learning. Also, I was ensured that everyone knew what we were doing in class, and the students understood it was their responsibility to see me before class if they had a question on the process. So as a result, we were all able to spend the entire class time on exploring the regression functions, determining which was best for the data, and then using that function to predict future results. Students loved it as much as I did because they were able to achieve mastery of the prerequisite skills on their own and then apply those skills in class to create new learning and deepen understanding. Another frustration in terms of time happens at the other end of the spectrum. You, the teacher, have designed this wonderful lesson, the students are engaged, and learning is taking place. Hooray! And then the bell rings, or whatever the equivalent is for run out of time in your classroom. Now what? Just when you get them to that place, you know the one, the place of excitement and engagement and questioning and thinking and general good stuff, you run out of time. So the class that comes to my mind for this situation is geometry and measurement, particularly the lesson on logical reasoning that precedes the initial discussion on proofs. The lesson is already an ambitious one, learning all 4 forms of valid logical reasoning. Now, using a strategy similar to that discussed in the first scenario, I ensured that the students entered the room prepared to learn. However, I ran into another problem. It took until the very last few minutes of class to get there in terms of student understanding. So that meant just as we all arrived at the longed-for teachable moment, time was up. In this case, I continued the discussion and the learning after class via an audio-visual tool called Voki. Students were asked to demonstrate their understanding and mastery of the 4 forms of valid logical reasoning after class. Specifically, each student went to the Voki site, selected an avatar, and then created a 1-minute recording in which they explained, in their own words, the 4 forms. These recordings were then posted to our Common Class discussion board in the LMS. Students were then requested to view at least 3 classmates' recordings and comment specifically to indicate their assessment of the level of understanding demonstrated. In this way, students were asked to both teach and also to assess others' teaching efforts. By extending the teaching and learning time after class was over, I was able to get a better understanding of my students' level of knowledge, and it allowed them to share their newly acquired knowledge with each other, realizing that the teacher is not the sole provider of understanding, but that it's a shared commodity among everyone in the class. Type of professional development and the specific ideas from hybrid teaching in mathematics will awaken you to the potentials in your own students, motivate you to learn more about this approach, and inspire you to use your classroom time more wisely. Questions that you have. If you think of something later that you'd like to ask, or if you're interested in learning more about Rimway and the services that we offer,